Today we are going to learn our very last gas law, and it is known as Graham's law. Graham's law is going to deal with the movement of gas molecules. So remember that gas molecules can do diffusion. This is where the gas molecules are spreading out in a container to take up the entire space, and they're going to spread out until they're evenly spaced. Gas molecules can also do effusion, which is the escaping of gas molecules from a container. And something to remember as we're working with Graham's law is that if gas molecules are at the same temperature and the same energy, then heavier molecules are going to move more slowly. So this is going to help you to analyze your rates that you're calculating, okay, and double check and make sure that you see that larger molecules are going to move slower than small molecules, okay? All right, here is our Graham's law equation. So you can go ahead and copy this onto that equation sheet that we have been growing throughout the semester. Here, the V's stand for velocity. That is a measure of speed. The units will be meters per second. The M's stand for mass, and we're going to use the molar mass. Okay, and so your unit there will be grams per mole, just like before. Okay, the A's and the B's simply are placeholders for gas A and gas B. So the first gas in the problem and the second gas in the problem. Okay, so Graham's law states that the rate of diffusion of a gas is inversely related to the square root of its molar mass. Okay, so that is just the description of the equation. And so what we're showing is the ratio of gas A's speed to gas B's speed. So let's do a couple of example problems and see how this is going to work and what kinds of algebra skills we need to have. All right, the first problem says, determine the relative rate of diffusion for krypton and bromine. Okay, and that's it. That's the whole problem. But this is everything we need to know using our periodic table for help. All right, so the first gas is going to be gas A. The second gas is going to be gas B. And it's asking for the relative rate of diffusion. So that means we're looking at that ratio. Okay, so let's remind ourselves what our equation is. And then what I'm going to do is I'm going to go ahead and replace those A's and B's with the symbols for the gases. That way I can make sure that I get my numbers into the correct location in the equation. So we're going to go ahead and replace the A's with the symbol for krypton and replace the B's with the symbols for bromine. Okay, there we go. Now notice here though, for bromine, I didn't just write Br. I wrote Br2. Why did I do that? Hopefully you guys said it's because bromine is a diatomic element. So that means that bromine gas will be Br2 because it's diatomic, it must be paired. Okay, so as we do this, knowing those diatomic elements is really important. So make sure that you go back and review those 7 diatomic elements. Make sure you remember what they are. We learned those back when we learned about the periodic table. Okay, next up, let's plug in some numbers. But there aren't any numbers in the equation. So where are my numbers going to come from? Well, remember that M stands for mass, and this is going to be my molar mass. So I'm going to get these numbers from my periodic table. That's that number in the bottom of each square of the periodic table. Okay, so bromine, if I look at my periodic table, it says 79.904. Okay, but it's Br2, so I have to multiply that number by 2, and that gives me the 159.80 grams per mole. Krypton, this is just krypton, it's not a 2, so I just take the number right off my periodic table, and I see that it is 83.80 grams per mole. Okay, now that I've got my numbers plugged in, all I have to do is put it into my calculator. But be careful. You have to tell your calculator how to do the problem because it doesn't understand how to do it in the proper order. So you have to tell it. You can either break it into steps. That's what I like to do. So in my calculator, I'll go ahead and divide first. So I'll do 159.8 divided by 83.8 equals, and I'll go ahead and get that answer. Then I'll say square root that answer. Okay. If you want to do it where you type it all in one go, you have to tell your calculator how to do it. So you would press square root and then parentheses 159.8 divided by 83.8, close parentheses. Okay. If you do not put your division in parentheses, it will not do it in the proper order and you will get the wrong answer. Okay. So be careful there. Calculators can trip you up sometimes. When we write this out, we see the answer is 1.381. Okay. Notice I didn't write a unit. Okay. I have grams per mole divided by grams per mole. That means they cancel out. This is one of the very, very few times you will ever have a number that doesn't get a unit, right? Because it's a ratio. But what does this ratio mean? What does this number mean? Okay, well, let's see. Remember that the smaller molecule travels faster. So we see that krypton here is 83.8. That is smaller than the 159.8. So krypton is going to move faster. And this number tells you how much faster. So krypton diffuses 1.381 times faster than bromine. Okay, that's what your number's telling you. How much faster. Now, sig figs here, there's no number in the problem. Right? So there's no number to give you sig figs. So your sig figs come from your periodic table. People using different periodic tables will have different sig figs because some periodic tables give more sig figs than others. So just be aware of that. All right, let's look at another example problem. Here we have a molecule of oxygen gas. It has an average speed of 12.3 meters per second at a given temperature and pressure. What is the average speed of hydrogen molecules at the same condition? Okay, so write down my equation here. And what I want to do is I want to put the unknown as my gas A. Okay, so once again, I'm going to go ahead and replace A's and B's with my symbols. So I know oxygen gas, so I'm going to put O2 where the B's go. Notice it's O2. That's another one of those diatomic elements. My unknown gas is hydrogen. What is the average speed of hydrogen? So that one's my unknown. So I'm going to put that where the A's are. H2, notice that's another one of those 7 diatomic elements. Okay, this is going to help me make sure I put my numbers in the correct locations. Okay, all right, so let's plug in the numbers that I know. Okay, so I have a velocity of oxygen. That's 12.3, so I'm going to plug that in there. And then I'm going to use my periodic table for my molar masses. My molar mass of oxygen on the periodic table is 16.00. Since it's O2, I have to multiply that by 2 to get my 32. Okay. Hydrogen on the periodic table, 1.01. I have to multiply that by 2, so 2.02. So that's where those numbers come from. Okay. Now, for this side of the equation, I can go ahead and do my math for that one using my calculator just like we did in the last problem. So 32 divided by 2.02, take that answer and square root it, or remember to use your parentheses in your calculator. Okay, and I get 3.980 for that. Now, and my units canceled off. Grams per mole divided by grams per mole, they're gone. Now use my algebra, since this side is being divided. To get that to cancel off, we have to multiply, do the opposite. So multiply both sides by 12.3. That'll make the 12.3 meters per second on this side cancel. And then we do 3.98 times 12.3. And to do my correct sig figs, I'll have to round a little bit. There's 3 sig figs in the problem, so my answer should have 3 sig figs. My unit is meters per second because notice this one didn't have a unit. We multiplied by meters per second, and so we keep that meters per second. Nothing canceled off. And my answer, I was looking for a velocity, so it makes sense that I have meters per second left over. Okay, so 49.0 meters per second. All right, let's do one more example problem. Here I have an unknown gas that diffuses 4.0 times faster than oxygen. Find its molar mass. So the first gas is gas A, the second gas is gas B, and we remember that ratio, we have the ratios 4.0, so that goes on this side of the equation. Okay? Always put your unknown as A. Okay, so I'm going to go ahead and replace my B's with my O2 because that's the gas that I know up here in the problem, O2. And then we can fill in. So we know this whole side of the equation, the ratio, is 4.0. Going to our periodic table for the molar mass of oxygen, it's 16.0. Got to multiply it by 2 because it's diatomic, and that gives me 32 grams per mole. And then my unknown that I'm solving for. Okay, so now I just need to use my algebra skills to solve for that unknown. So since this is square rooted, the first thing I have to do is get rid of that square root. To do that, you square both sides. So the opposite of a square root is squaring, so you square both sides. 4 squared is 16, and when you square a square root, everything stays the same, you just get rid of that square root. Okay, and so then we are at this step. Now we have to get this on its own, so if we multiply both sides by m, then we get 16m equals 32 grams per mole, and then we just do 32 divided by 16 so that we get that by itself. Okay, so there was an algebra step that I did in there, so if you are getting confused of how I got to right here, then get into contact with me so I can help you out in developing those algebra skills. Okay, so we need to do 32 divided by 16 equals 2.0 grams per mole. Okay, so the molar mass of my unknown gas is 2.0 grams per mole. Okay, if you have no idea what's going on, you have no idea how to use this equation, or if you're getting stuck with the algebra, get into contact with me. I will work with you. We'll do things step by step until you get those algebra skills and you understand where numbers are coming from and where numbers are going. Okay, because up next is your independent practice. So if you need help, get the help before you try that assignment.